Here's a little tricky proof that's on the syllabus. To prove the cube root of 5 is irrational. So this is a proof by contradiction. You should always say that then. Right at the start, proof by contradiction. Assume that the cube root of 5 is rational. Make sure you've said p and q are contained in the integers, and make sure it is stipulated that p and q is written in its lowest terms. In other words, they can't both be even. They can't both have a factor of 5. They can't have anything in common. They can't have any factors in common. So when we write this down, deriving from our assumption, what we can say is that looking at this, p must have a factor of 5. If p cubed is equal to 5 times something, then p must have a factor of 5. So we can write that. P has a factor of 5. But if it does, then I can write it in this way. I'm going to let p equal 5k. K is an integer. And then I can replace p in this equation. And I get 5q cubed is equal to 5k cubed. And I can then multiply that out and simplify. And I get q cubed is equal to 5 squared k cubed. Now this time we're saying, well, q, when it's multiplied by itself 3 times, ends up having a 5 in the answer. And that means that q must have a factor of 5. So therefore, p and q have a factor of 5. So we say, oh, that's a contradiction. P and q cannot both have a factor of 5 because p and q is written in its lowest terms. And so, hence, the assumption is wrong. That's it. Really nice.